I don't know why, but this little adapter in the middle is needed. Uh, there's a pop voice, lapel microphone, lavalier, as they say. I don't know if it's a real, I don't know if it's a true lavalier in the true sense of the word, whatever that is. Either way, I'm going to take a lavalier attitude. All right. Welcome. Welcome, my 0 viewers, to my stream uh, that has had 9 peaks. Thank you. Thank you for stopping by. Um, just forgive me while I get all this together. Ah, what a day. I slept late, so what are you going to do? I was up late. Still working on the release stuff, but you can see where I'm at now. It's coming along pretty well. Let's get back to GitHub Desktop here. Yeah, I'm using the mouse today a little bit. Um, let's bring up Twitch here in tablet so that I can see it. Any live chat that's going on. Let's go to my channel here. Inky Head. Inky Head is up and running. I always hoped I'd be more of like, get up there and be controversial and talk to all kinds of crap about things. Here I am. I just want to pause this so I can see the chat more. There we go. I kind of just want to watch the chat here. Hopefully that'll work. I want to be able to see it. What's going on in chat? Let me see if I can do a little chatting myself. No. Chat. There we go. Welcome to my stream. Switching to YouTube. To YouTube at the top of the hour. I don't know why. I just decided to schedule a stream at 4 o'clock on YouTube just so I could test YouTube with OBS on this machine too. We're doing Mac Studio Ultra, you know, trying to push the limits, see what we can make this thing do. So you can tell I shifted my camera over and my upper part of my desk over a bit. May need to move that to a more central locale. There we go. Hey, welcome. So let's take a look at where we're at. Yeah, I was gonna take a peek at. Oh yeah, we're not looking at these yet. I was trying to figure out where the dependencies were, and the way that I was going about that was the way you would expect. I would try to do a build. I would first move pins up here and see, okay, let's do a build, see what happens. And, oh boy, things happened. So, yeah, I guess that's just for convenience. Hell.h. I don't know why that isn't in hell.h. Makes sense, right? That it should be in there. I don't know. Oh, because Marlin depths? Well, it shouldn't matter then. Still be in there. I think, unless for some reason it'll cause issues. So this is more like on there. Define, define, define. Everything is a define. And then you can see that this does depend on use watchdog, and so it actually depends on configuration. So it depends at least on Marlin config pre. This gets a little bit windy, but platforms, busy, it doesn't do it either. Like it would want to include Marlin config pre in platforms.h, but it includes platforms.h. So what happens when you do that? Well, what happens is that platforms.h includes it. It sees that this is here, but it ends up not including it again. It includes everything that follows, and then it tries to do everything, and therefore this could reasonably be stuck at the end here after conditionals ADV. Platforms is included early because it's the first thing we can determine is, from the compiler itself, there are flags set in the environment that tell us whether or not we're in AVR or on SAM or on teensy. So all these are our hints, and then we define the HAL path according to which HAL it's going to open when you use HAL path. Then HAL path is used throughout Marlin in various places whenever something needs to be included from the HAL, which isn't a lot of places. We try to limit that, but SPI, for example, one of those things. All this could be somewhat avoided, but well, here you see if I just included Marlin config, it would include more stuff that I don't necessarily want. Try to be minimal in what's included, but you try to be maximal, where you try to include at least at what is mentioned. So for example, here, I don't need anything really. This doesn't have any dependencies per se. So we could not include anything, but this one clearly requires I2C address, it requires HAL ADC resolution, it requires use watchdog. So it really should by rights include Marlin config pre.h. And that's what I'm going to add. I believe that's one level up. Yeah. You can see why I split these up into two. It's sort of like why the configs are split in two. There are things that it has to check in the conditionals, and then it sets some flags, and then you can carry on from there in the ADV file with a few little wrappers so it knows what's going on. Now you could lay the whole config bare, kind of like you do in when nothing is nested inside of another thing. You can see configs are nested. That would be interesting, an interesting approach to try and like put all these loose, get rid of this, if enabled, get rid of all these if enableds, boom, you just have everything. If excludes greater than 3, who cares? It's there, but if you don't, it's not used, it's not used. Part of the problem is that if you go to look at all the symbols that have been defined by the precompiler before things get to, say, a CPP file, every CPP file goes through the process of including a whole stack of headers, including this one, starting, it's one of the first ones, and all the macros and all that. And so it's all these symbols get defined right away. And the more you have, the more clutter you have, the harder it is if you were going to go sifting through it. I haven't done a lot of sifting through the pre-compiled symbols, to be honest, but when we run scripts that do things like look at what's been defined and so forth, it actually does help a lot, because now we have scripts that save the configurations as emitted by the compiler, because you can precompile, like we have a file that we do a precompile on. It's called dependencies, and it's just a header file that gets included as part of deciding what's going to be included as a library, or well, I should say, as which HAL is going to get included is flagged by these sorts of flags. All these defines get used by the precompiler process, like scripting in Platform IO, through something called scons, SCONS, which is sort of a what you would call um, organized build system, I guess, organized scripting, step-by-step step system. I don't know what you really call it, but it provides it basically provides a Python environment within which you can then like grab values, look at them, use them for different purposes out of the environment. So, for example, I could find if this was defined by the compiler, I could do a precompile, and this symbol would get emitted into a file, and then I can use this to look something up in another file. Going through this, like all this stuff that I'm talking about is like custom scripted. So we actually have a little precompile step in this. Marlin has gotten complicated. It's like a little machine. This just building it itself invokes a whole set of programs that have been written. It's crazy. Uh, but yeah, it's all there as just support. The early idea of the scripting stuff was, well, we'll create scripts and we'll just have them be, you know, quick, simple, dirty little things that just, patch this and that. Because, well, start at the beginning. Platform IO, scons, its system, however it is defined. Let's just say Platform IO has this stuff in it. And we'll say that scons is elements of that. And I might point some of those out where things are scons-like or things are specific to Platform IO. Like you could say that, let's say, it starts out with an INI file called, in this case, just platformio.ini. This is what it loads when you go to build Marlin. And the first thing it does when you invoke platform.io, and you have to name what environment it's going to run. So by default, it'll pick this one if you don't name one. So whatever you have filled in here, it'll use that. But typically, you'll use something like Marlin Auto Build, and it'll invoke this for you, and it'll fill in this in for you based on the motherboard inside the configuration file. So it's doing its own look at that and pick this. But what this then does is then it includes all these other configs because we split them up. At some point, it was one big file at one point, and then it was like, okay, time to split them up. Let's look at how that works. Fortunately, it was not hard. First time I tried it, didn't work so well, but then I got it working better later, thanks to the team at Platform.io. Is, by the way, also open source, very responsive. You write pull requests to them, and if something's broken or I want to tweak behavior, I can ask them to do that, and they do. It's really awesome. Sometimes, if it's a good idea. Recently, I was like asking some dumb question, or it was a pretty reasonable question. I was like, I noticed that the INI file, this file, was always opening every time I opened the project inside VS Code, and it turned out to be an actual behavior that was flaggable, so I could turn it off with settings. So turn that off. It's nice though if this was all your settings that you had, and it was a small project, you had one build target or whatever. This gets really complicated really quick. We have all these files, one for each platform. So AVR do, basically each HAL or whatever has a corresponding. Some of them have multiple ones, but corresponding INIs that are used, they're all loaded. So they're all up here. I opened up that folder. But then it fills in a common environment. So each of these is like, that's the name of the environment. Common. This is, so you set a base one. Platform is kind of the most base one. These are the settings that platform is going to pick up and use for its own purposes. These are common settings that you will use for your builds. And then you filled in, and then these names are all sort of, you'll see these over and over. Build flags, is the flags that are going to get passed to the compiler. Extra scripts are the scripts that will run, and somebody could run before build or after, for example. And then there's scripts that run at a certain other stage that have no prefix on them. They're exactly when they run. They're not pre, they're not post. Anyway, then libdeps is like libs libraries that you'll bring in. It's empty to start. And then you have all these are the filters. These are the files that will not be will be included or will not be included in the build. And so you actually have this really awesome capability which you don't have in Arduino. Maybe, well, the new one I think is based on this kind of stuff. It's based on Eclipse at least, and probably uses a similar build system. There you didn't have in the previous version the option to just keep some files in your project that are inside your project out of the build. If you wanted to not build something, you would basically, one way to do it would be to package it up into a library, and then don't use the library, then it won't build. But if you want to have things be in your project, it gets you can do you can also do libraries, which may work at some point. They're handy because they get pre-built, and then the linker line ends up being smaller at the end. Or you do something like this where you just say don't include any of these files, none of them, boom, and you name all the files that will not be included. And these are pretty specific: backlash, bed corners. Could say menu altogether is also not included, but you have to specify. If you're going to later say, oh, I want menu, but I don't want this, you have to just say, okay, I have to name all the things I don't want to get enabled when menu gets enabled, by the way. That's what this is for. We start out by disabling all these folders and saying don't include these in the build. And it's a small pile, but we've been adding them slowly, so it started out, piecemeal. But they're kind of grouped together a little bit. Eventually just kind of alphabetize them, really. But these will all be not included, and then we can flag them to be included later based on features, which are the flags you set in configuration. So we can pick those up, look at configuration, decide, oh, we're going to include, menu now because we have a menu turned on. So all this code will now get compiled where it wouldn't before. So you can have very small builds that go like that, which is nice. In Arduino, if you go to do a build, it'll try to build all the files, and all the files have to have wrappers on them that say, oh, I only build when, for example, HAL AVR. I only build when I'm on an AVR system. It's the only time I build. So, that's one of the necessary steps to accommodate old Arduino. The newer Arduino, look at it more, but it's going to have a better build system in lots of ways. I'll do a review of that because that'll be interesting. I'm really interested to see where it's at. It's finally matured. It kind of went through a couple of phases. There was an online version of Arduino IDE, which was interesting. Still there, still kicking, and they're going to do this one also, since it's based on Electron and Node in the background. I'm sure it'll do the same thing because you can do that, deploy it much more easily as an app and as a web app simultaneously with mostly the same code. It's very cool, very cool. So let's take a look at where we're at. So I was just peeking at, first we were looking at this, the serial port crap. Yeah, looking at the version stuff. So right now, I think I was doing another experiment. Oh yeah, moving things around more. Move extern HAL. Where do I like that to be? That seems pretty independent, huh? I guess it has to go. Oh, it can go there. Interesting. Okay, well, yeah. Very good. Platforms.h, which it includes, I'm sure. Yeah, we are good. So yeah, I'm gonna push this up here. Doing this already. Head 2. I don't have to do an F on it though. It's kind of testing. I have 52 tests running, so for each time I push one of these, GitHub will start 52 tests, which are just build tests. They're just which combinations of options. And there's a lot of different combinations that can affect things. You should do a very clear audit of how options affect the build and decide on what builds to do and in what order and what platforms. I mean, we test a smattering and try to cover things whenever there's a new feature. We turn on a test, create a test for it somewhere, either within existing tests or a whole new test. But yeah, so basically we try to get it to build with that option. And yeah, that can be a challenge to get the tests right. So again, it's another one of those things that turned into a small pile here in the project. Started out with, oh well, let's do a test. Sure, let's use GitHub tests. Okay, let's move on to that. We were using Travis. I keep talking about things in a roundabout way, but yeah, I want to at least give you some idea of when I'm talking about tests. What do I mean? Well, GitHub offers continuous integration testing, which is like anytime you push some change, you can have it run tests on it, basically. Or it's going to do a build, or depending on what your stuff is, you could have a project, for example, with shell scripts in it, and your test is it's going to run the shell scripts on the server and get the output of those scripts. So it actually is going to run the code, for example. We don't run the code, we just build the code. So it's a little bit different. We just do the compile step. Running a test would mean doing a native build, which would be a whole, which would do one of these, and they're pretty quick. Couple 20 would do the downloads and everything, maybe 40 seconds at the maximum to do a build once it starts. I think native build. Um, so using Platform IO again. So with a native build, you could do something like you'd want to test the core elements. So you would do a build with like a bunch of axes, and then it would run. You would start it up, and you would pass it a test flag or whatever. And when you did the build, you would pass it a test flag, so it would include all this test code, and then you would basically pass the test flag to it, and maybe other flags, what to test, whatever. And basically, it comes back with a bunch of reports, what it tested and what the results were, and if it'll just return a final pass or fail, because that's what you get in shell scripty world, or in CI world. You can pass, in which case it'll come out green with a check mark, or it'll fail and it'll have a big red X on it, and you must fix it. So that's kind of taking advantage of the GitHub continuous integration to test changes is tempting. I try to do testing on my end when I can using the scripting that I have here, which takes advantage of the same scripts that we use for the testing up there. It's all interconnected and shared. So when you do tests on GitHub, you have something called a YML file in a workflow, and that workflow can have any name at all, but we call it test builds, so it's clear what it is. Do test builds to catch compile errors, and then you just fill it in with a bunch of info in YAML style. YAML markup looks like this, and it is sort of structured, and it comes out kind of like you'd expect, sort of like an analog to anything that's structured XML, JSON, but YML looks like this. Even syntax files in something like Sublime or TextMate are basically the same kind of structure, but not necessarily the same format. But anyway, this is pretty cool stuff. YAML is very handy. It's very readable. You can pretty much tell just by scanning this what's going on. When there's a pull request on bugfix 20x, and it doesn't happen to these files, then we invoke or on a push, same idea. Then we run test builds, jobs. These are the rules, basically, and then these are the things that will be done. So test builds happens, and we put it on, give it a name, you give it, make sure it only runs on Marlin, not on forks. So I used to run on forks and get a lot of messages. Whoops. So that fixed that. But yeah, we run all these tests, and each one of these is, this is just a thing called strategy with a thing inside called matrix, and that determines how things will be sent to your script or whatever that runs here. So each of these things in this list, given this name, this matrix called test platform, will be sent to you one at a time, and each of these names will be sent to you, these words. So these just happen to be the names of tests, and those tests happen to correspond to files. So again, you can see we have many tests now. It's another pile. But yeah, the tests are inside of build root tests, and there they are. Look at them all. Aren't they lovely? And each test has options that it sets, and then a build is run, and then they return true or false. Ran, success or fail. That's pretty much it. Success or failure. We could do some asserts during the build, but for the most part, and we do a lot of asserts during the build, like sanity checks. So for example, sanity check to find an error in a configuration file or whatever. Anywho, yeah, and then it does these steps, which is like, so using this strategy, I want you to do these steps. That's what this thing is, this action. And so it'll do check out the PR using this particular action, which is just hosted on GitHub's under this path, essentially. And then pip cache that, and then cache platform IO. So it does it uses the cache, and then it does some things, pip platform IO, blah. So it's caching certain folders. In this case, my platform IO, blah. And then we use Python 3.7 to do an install of pip using pip again, and we picked 525 for our tests for now, because develop is a little mercurial. So I just needed something we can depend on while getting this release ready. But that'll be fun to play with later. Develop again was what we used to have here. And that gave us we're spearheading tester platform IO, because we get to run it like dozens of times a day, and anytime that there's an issue in develop, well, we're the first to find out, and then that we're being monitored carefully by the project. So it's very symbiotic, a symbiotic relationship between us and platform IO. Run tests. So then, yeah, this one is just called run, and then it actually fills this in with its own little cookie or token or whatever, and each of the platforms comes out and it runs the tests. And then when we go to look at tests on the website, you can see, hey, here's all the checks that it ran. There's 52 of them. These are running now, actually. You can see it's doing each of those steps. Complete job, post cache, blah, blah, blah. So right in the middle somewhere is run. So yeah, here's where it ran the tests, and it came out with not a green check mark. Anyway, it's a gray check mark. But yeah, all these passed, even though there were little, glitches here and there, but those are not necessarily our glitches. So yeah, so that's kind of how the testing works in here. It's pretty cool. So we get, so that's kind of what I just did there, pushing that one thing up, and now it's actually GitHub Desktop now gives you a direct access to tests, which is nice. It is fairly new feature in GitHub Desktop. Thanks, Mish Manners and the rest of y'all. All right, and what do we got? Where are we at? I still have the debug stuff to check out, but that was working the last time we gathered. I've got about 18 minutes now before I have to go and switch over to YouTube. But you can follow me there. I'll put up a link to where that is. I had set it up on the laptop, but I hadn't set it up necessarily over here. I think what I do is I'll just I'll use the connect method, connect my account, and well, you'll see how it works, or I'll see how it works. But yeah, I believe you just connect. It'll show you the stream that you're supposed to be connecting to, and then you just go, and all your scenes are all ready to go. I set it up on the laptop so I could get out and go outside, but it's been like in the mid 90s, so like I do love it, but at the same time I'm like I need to make a big pot of tea. Which, by the way, I learned that black tea is really a huge source of fluoride, which is great. You know, if you have it sparingly, it can be good for your teeth, I guess. But if you have too much black tea, like lots of it, if you watch Brew, you know what I'm talking about. But yeah, like it's bad for your bones and shit. It'll start to leach calcium out of your bones, turn you into Mr. Glass. Mr. Glass with kidney stones. So if you can imagine Mr. Glass even more cranky. Where are we at? Okay, yeah, look at 20x. Yeah, so at this point, I do have a tag on here, but I'm waiting for one little thing, which is some Pro UI checking. I did a consolidation where I took the Pro UI changes and squished them down. Should have a number on that. It's number 21. I have it open here somewhere. April 22. Yeah, it's for some reason it's still not building under CI. There's some underlying issue with CI itself. For this just this one particular thing, even though I've rebased it, which is strange. So I'm letting it lie until I figure out what's going on. But for now, yeah, it's being really strange. Like it's not using develop.zip, I'm pretty sure. No. So I don't know what's going on with it, but anyhow, yeah, so at this point, this is just, I consolidated all the changes for the Pro UI update, which, you know, pause and enjoy. But yeah, there's not a lot. It's mainly in the DWin menu and the addition of universal bed leveling tools, so some extras. Basically bringing UVL to this screen. And you can see it's actually it's pretty fancy. There's stuff here that would be great if we backported it. Maybe it's hard to do, but because, you know, for certain things, like you want to have a screen where you change the colors or whatever, you're not going to necessarily backport that part. But it's like, that's the tricky bit, is like, how do we backport this to our menu system so we could have a screen that it calls, that it draws in its own way. All this, I mean, these are a lot of data. There's a lot of data on these screens, but it's always in the, this particular one is always in the portrait orientation. So it gives you a certain amount of space, a certain amount of leeway, a certain amount of guarantee of, you know, well, that's the thing. When you have a platform that is completely self-contained, you can completely control it. You can do all the things without worrying about the idea of backporting and making things work under a different system. But at the same time, like there is a system that's just, you know, maybe it's imperfect. Maybe we can improve it. This these screens are fairly free to use RAM and do alloc and stuff. So this has a menu system that's a little more alloc-y, malloc-y. It's got a lot of malloc-y in it. But yeah, it's also, but with the Marlin UI menu system, it's meant to be geared towards being very concise, um, where everything is combined. So there is no like data structure. There is no, you know, filling in that data structure at runtime and so forth. It's just code, and the code itself is all the data is embodied in the code itself, in the calls that are being made. So in a way, simplified. Um, Everything's in line, sort of, so to speak. But there's a lot of stuff that's I say it's in line, but it'll call something if it's static or whatever. Call out to the bigger things, of course, but the menus and things like the title and how it's going to be how it's going to edit when you press the button. All the logic for doing that is all inside each menu item. Um, Maybe is bloaty, but it seemed fairly concise when I compared it to doing the same thing using data structures and having things be, oh, well, now you have to have a special case data structure. I mean, that's as it is now. We have like um, things which are special cases, then we try to generalize them. Uh, but some things, like a mesh editor, you could do that so many different ways. So it makes sense to just have, everything gets you figure out some API that works for all your screens for the minimum. Like, okay, draw the mesh. Yeah. You go to some high level, draw the mesh now. Okay, tell me when someone clicks clicks a mesh square, and tell me what the XY is. Have some interaction like that. And you just have your screen on some other end. Like maybe you have a knob that moves a cursor, and when you press it, it sends an XY. Whereas on others, you have a touch, and when they touch it, it sends the XY. But either way, they get the same interface. You build things to that degree of concision or whatever. You got to decide, ahead of time. Or what I've sort of tried to do is let things evolve organically within Marlin up to a certain extent, and then what we try to do is look at that new structure that's been introduced and see if we can bring it into the existing one, or if the existing one can be modified to better work like what looks better, if something new, better arrives. And that's kind of the thing is it's a cultural melting pot in that way. um, but yeah, so certain things are cool. We have the process of commands now. It'd be neat to have a print v version, a printf version of that, so we could just have one line that does all this at the same time. G code process printf. I don't know what you'd call it. Process of underscore p. That would pass all the things. You can actually write your own functions that do this, but each one has a little loop in it. Doing it this way, I'm just taking advantage of printf already existing, and it's already existing. Just combining the two would be fun, but redundant in a way. I think there is a way you can set up a function that would take a thing and then another thing and then an indeterminate number of other things, basically. And then we'll take those and pass them on inside the function to some things, to the So it's possible it could do that without having to go to the the whole process of actually making my own printf. I just have it do this trick. But that just because fewer lines, is always nice. And we do that. We do that in a lot of places where we create a string that's got G code that's filling in values, and then we send it on to get processed. So combining that would be sensible, of course. One thing you'll notice in Marlin is we don't use the string class from Arduino. is interesting. And the reason for that, I think, is that it's well, there's bounds to it, but it would be interesting to experiment and see what that's about. Um, is that one line by itself? I guess it is. It's just way on the end of the line. End of the line. Oh, I see. It's just very long, and then it's got. Okay, makes sense. Looks weird in the when I look at it in here, but long lines are bound to do that. Okay, so we're good. As much as I can shrink this, thanks to Electron, you can do that all day. Where are we at? It's getting pretty close to setup time for my 4 o'clock. Why did I pick 4 o'clock? Sorry about that. For my YouTube stream, it's not that inconvenient. You just click over to another tab. And anyway, there's no, there's not a lot of viewers here. I'm not inconveniencing the world. So what I wanted to get to was just, yeah, where is 2.0 and 2.1 at? Yeah, I'm waiting for those changes I just sort of briefly displayed. Not those, but the Pro UI screen updates, which are not passing, but that's fine. You see I've got the versions ready to go. I actually went through the configurations and I matched them up. So I have an import 2094 branch ready, which has all these changes piled up. And it's not published or anything, but these are everything after the last one, which I guess you could call patchy patch. I don't know what this is. Import to bug fix. So all these things are in sort of an order of things that apply fine for 2094, and that will include none of the Pro UI changes will affect this, which is good. There may be a couple other changes in the interim, but yeah, I'm about ready to tag this 2094, so that's great. And you know, typically I would tag that git tag imp dash 2094. And I'm going to have to create an import 2.1 branch. Well, I've done that. I'm going to have to start doing import 2.1x branch soon. These imports don't get published, but the release version of this will get published. And then anything that needs to be added would get added on top of it. So it just works out fine that I don't need to re-import branches and republish them. If I do, I get those done early and I keep them here until I feel confident. So yeah, this one is going to have pretty much everything from bug fix minus this is one of the things that's been added. It's being added. I rebase this. This is not rebased. It's all just, you know, bringing in commits as they're ready, and they can be shuffled around at will. But yeah, then the final thing that happens is you pull out all the things that are unpublished in bug fix. So features that are not yet done but needed to be in the bug fix branch so that those pull requests could pass. It's strange. But yeah, anytime I do a config change, this is what I'm sort of at, because I move the configurations over to a separate repository. Now I'm pulling in something that has to correspond to each pull request. Rather than publish a separate branch in configurations for each pull request, which could by rights do. But the thing is, those would have to be maintained and kept up to date in some regard, at least to the point where the thing can build. So I don't know. I may have to consider that. It's not such a terrible idea, but well, actually, it is a terrible idea because every invocation of the continuous integration build CI stuff has the same stuff on it. There's no special flag you can add to a pull request to say, pull in the configs for the pull request only, please. Because it would mean that first, every pull request would be broken when you first ran it. You know, unless there was some way you could script it up a little bit. So you could have it say, pull in the thing if it exists, otherwise don't, otherwise pull in this other thing. I don't know, it gets tricky. But yeah, so anyway, what I've tended to do is just like let bug fix version of the configurations for the benefit of bug fix pull it, have stuff in it that's not ready for prime time. It's no harm if it's disabled and it's not even being included in the current code. So having these in here is no skin off my nose. It's just something else that has to be maintained with all the rest of the options. No big deal. And then I come to this stage, and when I do the release, I actually just yank them out. Oh, this never got in there because we never finished it. This still isn't ready. This would go with, you know, something like the SE. Well, CR6, I guess, in this case, yeah. So this one's not ready yet because the SE code is still being sort of bandied about. There's just changes inside the code itself that I'm not sure about, especially in the context of, you know, everything being sort of up to date now. So it will be in soon, but right now not. And there is stuff that can be tested, but there's also the community firmware, so it's not like you're missing out for CR6 people. The community firmware is really good, so go get her. All right, I got to start my 4 o'clock, so I hate to cut it off, but we'll come back to this kind of stuff. But yeah, the import 2 and stuff is getting ready. So I have configurations ready. Keep that open, I guess. On the Marlin side, 2.20 has all that. 2.1 is there. You can see it's based on 2.0.9.4, so at least it's a little cleaner in that regard. They actually have a common history up to this point. Then it's all marked off with the new config numbers, which is pretty much all it takes in the version. We'll also get a date update as well, which I'll take care of soon. I think the date might have already been updated, but yeah, I'll take care of that. It's an important part of it. Anyway, come over to YouTube if you feel like it. It's not like I'm doing anything different over there. It's just a different platform. If you have to put up with ads, well, you know, we have to put up with ads everywhere, don't we? I pay the $10 premium price, which is like my ransom for not having to deal with ads. And I'm happy to do that, frankly, but I do wish it was less. $5 a month makes more sense, really. But in these inflationary times, you know how it is. Inflation drives inflation. We can blame cryptocurrency if we want. Bitcoin, it's your fault. Anyway, see you soon. Bye.